Okay, sadly we're going to have to make a part 4 for this part of the video because my puppies wouldn't quit fighting over a rawhide, and so we had to remove them from the video making room so that we could go through this again. We were on number 8. We were talking about the intersection of line PS and line OS. We had traced PS in purple, we had traced OS in blue, and we realized the only place they touch was down here at point S. So right here, name the intersection of PS and OS. We would just write S. Again, we don't have to put point S, we just put a capital letter. And our explanation is two lines intersect at a point. And again, the reminder for that is on your other set of notes right here, where it says two lines intersect at a point. Okay. So, number 9. How many planes contain line LO and line OS? Well, again, just not looking at the picture, we need to look at how many points they gave us. They gave us L, O, here's O again, so we don't count it, and S. So 1, 2, 3 points. So that means it's either going to be infinite or one plane, depending on whether or not they are collinear or non-collinear. So let's look at line LO and line OS. So let's see, what color can I do it in? Let's try blue. So here is LO. Here is OS. So this one and this one. Well, L, O, and S are 3 non-collinear points. So if we go back to what our rules say, it says 3 non-collinear points make one plane. And again, we know, because to finish off that box, we would come over here to P, and then go back up here to L. And that's the only plane that would contain both LO and OS. So how many planes contain LO and OS? We would say 1. And again, this is because 3 non-collinear points make one plane, whereas 3 collinear points made infinite planes. Alright, last one is line, that should have an arrow over the top, line OM in plane LMN. Why or why not? So OM, let's go ahead and make that in red. So here it is, O to M. Here's this invisible line that would come across here like this. Is that inside of plane LMN? Well, I'm going to trace LMN. We're going to do it in my green marker. So here's L to M to N. Well, the rest of that would be here to here. So is this line inside of this plane that's on the top? Well, absolutely. It sure is. So we would say yes. And then our reason goes back to the very front, where it says if 2 points are in a plane, then the line that contains the points is also in the plane. Well, O and M are both a part of LMN. Therefore, that line is in the plane. So we would use that same thing. If 2 points are in a plane, then the line is in the plane. So, finally, we can call points, lines, and planes completed. Again, I know it's very abstract, so you're going to have a couple of worksheets to see if you can make it through. And again, if you have any questions, make sure you ask.